Chapter 9, Solving an Easier Related Problem. I'm going to list a few, six ways to solve an easier related problem that we want to go over. The first is to use a number instead of a variable. So let me give you a quick example of that. 3 students have an average height of 60 inches. A 4th person is added to the group, and now the average height of all 4 students is 62 inches. How tall is the 4th person? Question mark. So we have this information. I'll use x for the first person, x, y for the second person, and z for the third person, and we know that their average height is 60 inches. And then we're asked to find what is the average. We're given the average height of all 4 people. So let me throw another person in here. I'll call them A. And we know that that average height is 62. So the question is, how tall is that 4th person that I'm calling A? Well, it turns out we could substitute these variables with a number that makes sense. So even though this isn't the case, I could say that these first 3 people had a height of 60 inches. So really the problem then becomes 60 plus 60 plus 60 plus A over 4 equals 62. So what started out as a fairly complex problem with 4 variables that we don't know about, it turns out I'm allowed to plug in some number that makes sense for those first 3 variables, and it becomes a much simpler problem just solving for A, 1 variable. Alright, to solve this, I won't go through the details, but to solve this you'd multiply both sides by 4 and you'd get 248 on the right side, and then subtract these 60s off from both sides, and that would tell you what A was. The answer should be 68 if you want to try that on your own. Okay, let's look at a different way to solve an easier related problem. You can use a smaller or an easier number to develop a strategy, and then once you have the strategy, go back and solve the harder problem. So for example, if I wanted to divide 13 by 29, and I don't remember in my calculator, do I plug in the 13, hit the divide button, and do 29? Or do I plug in 29 first, hit the divide button, and type 13? So if I can't remember that, well, I could pick an easier number that I do know something about. So for example, I know that 1/2 on a calculator should give me 0.5. So I could try 1 divided by 2, 2 divided by 1, and see which one gave me 0.5. And of course, it's going to be this top one here. And that is where I took the top number first and the bottom number second. So that gives me a clue for the original problem. I would type in the top number first, and the bottom number second. Another example of this is if I wanted to solve a problem like this, multiplying 2 variables with fractional exponents. Well, let's say I can't remember what you do with those exponents, but let me replace those fractions with other numbers, 2 and 3. So I'm just substituting with easier numbers first to get the strategy, and then I'll go back and solve the original problem. So if you think about what this is, I know that x squared is x times x. And I know that x to the third is x times x times x. So that's x squared times x, And if I get rid of these parentheses, that's really x to the fifth. So if you look at how I went from x to the second and x to the third to x to the fifth, that tells me I must just add those exponents together. So now when you go back and solve the original problem, you know that you just have to add those exponents together. So in other words, the original problem would equal x to the, and I'll put this in parentheses, 2/3 plus 2/5. Now to solve this, you have to remember how to get common denominators. So it's x to the 2/3 times 5/5 plus 2/5 times 3/3. So that we get a common denominator between those fractions, and I'll have 10/15 plus 6/15. So I can add those together and I get x to the 16/15. Okay, let's look at another strategy for solving an easier related problem. You can do a set of easier related problems and look for a pattern, and that's the key, the pattern idea. But if you remember, this is really what we did when we did our chapter, our whole strategy on looking for a pattern. We were solving easier problems specifically by looking for a pattern. Once we found that pattern, we were able to solve the larger problem. When we look at another way to solve easier related problems, number 4, do a specific easier example to figure out an easier process for solving the original problem. Now I'll come back to this one in a second. The divisors of 360 add up to 1170. What is the sum of the reciprocals of the divisors of 360? So that seems like a really hard problem on its surface, but it turns out it's not too bad if we can find an easier example so we get the process. Then this will make this problem much easier. But let me come back to this one in a minute. Let's go down to number 5. We can change, fix, or get rid of some conditions of the original problem, and that'll help us solve the harder problem. So for example, I'm using this idea of learning to surf. Now, plenty of people do just go out and learn to surf, but what you probably do, especially if you take lessons, pretend like this is a surfboard, you wouldn't take this out to the waves right away. You would do this on the sand first, and you'd learn how to stand up on the board. You'd learn how to lay down and jump up really quick and try to balance on the board. Then you'd take it out to the ocean. So in other words, you're getting rid of the condition of the water as you're learning how to surf. So you can start by getting rid of some conditions and then slowly add back conditions as you get a handle on what the problem's doing. And then the last idea for solving an easier related problem is a fairly simple one. Just eliminate unnecessary information. And really, you've been doing this all along in this class. A lot of the problems we've encountered have had extra information about the story, the background story, but it doesn't really help you solve the problem. Sometimes it does, so you have to be careful about what information is you're considering unnecessary, and be willing to add that information back in if it turns out it is necessary. Okay, let me jump back to number 4 and this problem that we were going to look at solving. So first of all, it would help to know what is a divisor. Well, the divisor is any number that divides into 360 evenly. So like 2. 2 would be a divisor of 360. But I don't want to deal with 360. That's got a lot of divisors. Let me look at a much smaller number, like 14. The divisors of 14 are not that many. So 1, always the divisor of any integer. 2, because 14 is even, and 14 can be divided by 2. 7 is the next number that works, and then lastly 14, the number itself, is always a divisor. So I've only got 4 divisors to work with. Now, because the original problem gave me the sum, so it says they add up, the divisors add up to 1170, let me get what these divisors add up to. 1 plus 2 plus 7 plus 14 equals 24. Now the next thing we need to know is what is a reciprocal, and that is just 1 over a number. Or the way I'm going to think of it is, if I think of these original divisors as 1, 2, 7, 14, but over 1, so I've got 1 over 1, 2 over 1, 7 over 1, and 14 over 1. The reciprocals are those fractions flipped. So 1 over 1 flipped is the same, but 2 over 1 flipped is 1 over 2, so 1/2. 7 over 1 is 1/7, and 14 over 1 is 1 over 14. So the original problem wants to know what's the sum of those reciprocals. So I'm going to find the sum of these reciprocals and see if there's anything that would help me solve the original problem. So I'm going to add 1 over 1 plus 1 over 2 plus 1 over 7 plus 1 over 14. Now again, I'm going to need a common denominator. So that common denominator will always be the original number that I started with. So here I started with 14. So I'm just going to multiply each fraction by what it needs on top and bottom to get 14 on the bottom. So 1 over 1 just needs 14 over 14. 1 over 2 needs a 7 over 7, because I know 2 times 7 will multiply to be 14. And 1 over 7 needs a 2 over 2, because I know 7 times 2 will give me 14. Alright, so now what I've got is 14 over 14 plus 7 over 14 plus 2 over 14 plus 1 over 14. And if I add those all up, I get, well, let's see, 10, 24 over 14. Alright, what is interesting about this is that the top number is the same as the sum of the divisors, and the bottom number is the same as the number I started with. So we can apply that to the original problem and say that the sum of the reciprocals will be a fraction where the top number is the sum of the divisors and the bottom number is the original number. Or in other words, 1170 over 360. And of course you can simplify that, but we have our answer. Okay, that's it for easier related problems. Try some of the problems that I'm posting on the lesson today, and come find me in Discord if you have any questions.